Dear students, once again I welcome you to assignment 9, the solution part, and you have already gone through the various concepts on quality control charts, process capability and QFD, and this assignment was drawn to strengthen your understanding on these issues. So, again there are 25 questions and each question carries 1 point, and all the questions are objective type, only one answer is correct. Question 1, how do you find the process capability? A, by process capability ratio Cp USL minus LSL divided by 6 sigma. B, by USL and LSL. C, by normal distribution curve, and D, by spread and mean shift of the process. The answer is A, process capability ratio Cp. Specification width divided by process width USL minus LSL divided by 6 sigma is the correct answer. Question 2, in a certain process it is given that USL is 14, LSL is 0, the process has a mean of 10 and standard deviation 2, what will be the process capability ratio? 0.83, 1.17, 1.33, and the answer D is 1.5. So, the correct answer is B, 1.17. You can easily compute Cp is equal to USL minus LSL divided by 6 sigma is equal to 14 minus 0 divided by 6 into 2. So, it is 1.17. Question 3, in a process the inverse of process capability ratio is 0.65, which statement is correct? A, the process is incapable. B, the process is capable with tight control. C, the process is capable, and D, none of the above. So, the correct answer is A, CR you can find as inverse of Cp, which is 6 sigma divided by USL minus LSL. If CR is less than 0.7, the process is capable. If CR is equal to 0.75 to 1, the process is capable with tight control, and CR is greater than 1, the process is not capable. So, in the case given, the correct answer is A, as the value 0.65 is less than 0.75. Question 4, a process having mean 8.80 and process standard deviation 0.12 has spread of specification limit 9 plus or minus 0.4, what will be the process capability index? A, 0.55, B, 1.67, C, 1.33, and D, 0.83. The correct answer is A, 0.55. Process capability index is equal to CPK, and you have studied the expression of CPK as minimum of x double bar minus LSL divided by 3 sigma, or USL minus x double bar divided by 3 sigma. If you substitute the values, you will find that the minimum is 0.55, and hence your answer A is correct. Question 5, how CPK is different than Cp? So, there are 4 questions, 4 options. A, Cp looks at the centrality of the process. B, CPK looks at the overall variability of the process. C, both look at the overall variability of the process, and D, CPK looks at the centrality of the process. As you can understand, the difference between Cp and CPK, the correct answer is D. CPK actually looks at the centrality of the process, whereas Cp looks at the overall variability of the process, as the expression of Cp only includes USL minus LSL, whereas in CPK we find the minimum of USL and LSL with respect to mean. Question 6, a QC scheme is in operation for a process reducing a QC scheme is in operation for a process producing ball bearings. A sample of 6 bearings is taken every hour and diameters is measured. The mean diameter with the process delivers is 2 cm. A bearing meets specification within the range 1.998 cm to 2.002 cm. If the specification limits are considered at 1 sigma level, what is the process capability? A 0.11, B 0.44, C 0.22 and D 0.33. Answer is D 0.33, mean is 2 cm, specification 1.998 to 2.002. USL is equal to mu plus 1 sigma, which is equal to 2.002 as found. LSL is equal to mu minus 1 sigma equal to 1.998 as found. If you solve these two equations, USL and LSL, you will get the value of sigma, which is equal to 0.002. Put this value in the CPK expression and take the minimum, which is 0.33. So answer D is correct. Question 7. What is true about process capability index and process performance index? So you have studied two concepts, one is CPK, other is PPK, and you can look at the various statements. One, CPK tells you about what the process is capable of doing in future, assuming it remains in a state of statistical control. PPK tells you how the process has performed in the past and verifies is the process capable to meet customer CTQ, critical to quality requirements. 2. PPK only applies to a specific batch of material. 3. PPK generally uses sample sigma in its calculation. CPK uses the process sigma value determined from either the moving average, range or sigma control charts, and 4. Both the indexes are same. So the correct answer is A. 1, 2 and 3 are correct. Question 8. A process is having net weight specifications 9 plus or minus 0.5 with process mean 8.8 and standard deviation 0.12. The sample standard deviation is 0.11. What will be the process performance capability, PPK? You can see the 4 options A, B, C and D on the screen, and the correct answer is 0.9. B. LSL is 8.5, USL is 9.5, X double bar is 8.8, sigma 0.12, S 0.11, and process performance capability you can find using the expression minimum of X double bar minus LSL divided by 3S and USL minus X double bar divided by 3S, and minimum is 0.9. Question 9. How quality function deployment differs from conventional product development? A. It listens to the customer. B. It develops and manufactures towards measured goals. C. It optimizes products and processes, and D. All of the above. So the correct answer is D. All of the above. It listens to the customer. It decides what is important. It develops and manufactures towards measured goals, it minimizes variation from targets, and it optimizes products and processes. It is a proactive process. Question 10 is on the screen, and if a company is late to market to deliver its products by 4 months in shipbuilding industry, as a rule of thumb, not accurately, what is its impact? A. Gross profit potential is reduced by 18%, B. It is reduced by 33%, C. by 25%, or D. by 13%. You can see the answer A, that is gross profit potential is reduced by 18%, and also you can see the table which basically gives some rule of thumb and tells that what is the profit margin that you will sacrifice if you are late in launching the product. Question 11. What does the roof of the house of quality indicates? A. The customer requirements. B. The correlationship matrix showing the conflicts between engineering characteristics. C. The relationship matrix between customer requirement and engineering characteristics. D. The target value of the organization for the product. The correct answer is B, and you can also see in the given figure that what are the various elements of QFD and how they are placed in a typical structure of QFD. Question 12. What is the output from second phase of QFD? Design requirement, process operations, part item characteristics, or operations requirements? The correct answer is C, part item requirements. There are 4 phases as you have learnt in QFD. Number 1 is product planning, number 2 is product design, process planning is the third one, and process control respectively. So, customer requirement is the input to the product planning phase, and design requirement is the output from this phase. Design requirement is the input to product design phase, and part item characteristics is the output from this phase. Part item characteristics is the input to the process planning phase, and process operations is the output from this phase, and subsequently process operation is the input to the process control phase, and operations requirement is the output from this phase. Question number 13. How Kano model is different than QFD? QFD gives information about delighted needs. QFD distinguishes the quality of requirements. Kano model captures the voice of customer. Kano model captures the mind of customer. You can see that from the very fundamental definition and the purpose of this Kano model and QFD, that answer D is correct. Kano model basically deals with the mind of the customer, whereas QFD captures VOC, that is the voice of the customer. Kano model distinguishes between basic needs, performance needs, and delighters. Question 14. Which of the following statement is true regarding Kano model? A. Threshold attributes are those for which more is generally better. B. Performance attributes are the expected attribute that must be there in a product. C. Excitement attributes are unspoken and unexpected by the customer, and D. None of the above. So, the correct answer is C. Threshold or basic attributes are expected attributes. Performance attributes are those for which more is generally better, and excitement attributes are unspoken and unexpected by customer but can result in high level of customer satisfaction. Question 15. Which of the following statement is incorrect? Quality function deployment A reduces product development cycle time. B increases engineering changes. C reduces startup costs. D helps to identify specific competitive advantages easily. The correct answer is B, and you can go through the various benefits listed on the screen are the benefits of QFD, and hence the correct answer is B. Question 16. Which step is out of DMAIC? Measure, improvement, control, design. The correct answer is D. DMAIC is define, measure, analyze, improvement, and control, and there is nothing like design. Question 17. Which of the following statements are true about value stream map? Number 1, links the material and information flows. 2, ties together lean concepts and techniques. 3, less useful than quantitative tools. A, only 3, B, 1 and 2, C, only 2, D, 1 and 3. You can see that the correct answer is B, 1 and 2, and value stream mapping is one of the very important tool in lean management, and basically it analyzes the current state and future state for the series of events that take a product or service from its beginning through to the customer. Question 18. Checkout time at supermarket is monitored using a range and mean chart. 6 samples which contain 20 observations per sample have been collected, and the sample means and sample ranges have been computed as given in the table below. Which chart should be used first to analyze the checkout time variability? U chart, S chart, mean chart, range chart. You first look at the nature of the data, whether it is of variable type or attribute type. If it is of variable or attribute type, then what could be the appropriate chart for controlling the variability? So, the correct answer is D, range chart. X bar and R chart is a pair of control chart used with processes that have a subgroup of 2 or more. The standard chart for variable data. X bar and R chart help determine if a process is stable and predictable. Question 19. Which chart is used when the control chart is having quality characteristics as attributes and defective with constant sample size? A, P chart or NP chart. B, C chart or U chart. C, X bar chart and R chart. D, X bar chart and S chart. So, the correct answer is A, P chart or NP chart basically are used with yes, no type attribute data, and these two charts are commonly used to monitor the fraction defective P or number of defective items in a subgroup of items. Question 20. What are the formula used to find the control limits in U chart? So, you are given the 4 options A, B, C and D on the screen, and you can find out the correct option, which is D, USL is equal to U bar plus 3 square root of U bar divided by Ni. LCL is equal to U bar minus 3 square root of U bar minus Ni. You can see here that Ni, it means you can have different sample size. Question 21. Mean values and ranges of data from 20 samples, sample size is equal to 4, are shown in the table below. What are the central line and control limits for our chart? Serial number 1 to 10, mean of sample 10, 15, 12, 11 and so on, range 4, 4, 5, 4 and so on, and similar way you have the sample number 11 to 20 in the next column. Now, the options are A, B, C, D. Central line is equal to 4.15, UCL is equal to 9.47 and LCL is equal to 0, and same way you have B, C and D options on the screen. The correct answer is A, and you must be interested in referring to the solution. So, the solution is like this: R bar sigma I is equal to 1 to 20, R divided by 20, which comes out to be 4.15. Upper control limit of R chart is equal to D4 into R bar equal to 9.47. Lower control limit of R chart equal to D3 into R bar, this is 0. So, D3 for 0 for sample size 4, and the correct answer is A. Question 22. Mean values and ranges of data from 20 samples are given in the table below. Same data which is reproduced here, used in question 21, and here what are the central line and control limits for X bar chart? So, you can look at the 4 options A, B, C and D on the screen, and the correct answer B with the computation sigma I is equal to 1 to 20, X bar is equal to 232. So, X central line for X bar chart is equal to sigma I is equal to 1 to 20 X bar divided by 20 equal to 11.6, and you can use the tabulated value of factor A2, which is 0.729 for sample size 4, and you can compute the upper control limit and lower control limit of the x bar chart as x bar double bar plus or minus A2 R bar. Question 23. A bank manager receives a certain number of complaints each day about the bank service. There could be different types of complaints, but here putting together just the number of complaints are presented in terms of day as well as number. Complaints for 14 days are given in the table shown. Find out the upper control limit and lower control limit, and the hint is also given that use C chart. So you have 4 options available on the screen, and you can compute it using the upper control limit, lower control limit expressions for C chart. The correct answer is D. UCL is 10 and LCL is 0. C bar is equal to 56 divided by 14 equal to 4. Sigma C bar is equal to square root of C bar equal to square root of 4 equal to 2, and UCL LCL can be stated as C bar plus or minus Z square root of C bar, which is 10 and 0. Question 24. Match the following: X bar and R chart on the left side, second is P chart, third is C chart, and on the right side you are given 3 different distributions. Which one is the most appropriate one for an individual, say, control chart? And you have 4 options A, B, C and D on the screen. The correct answer is C, 1C, 2A and 3B. X bar and R chart, basically application of normal distribution, and we are dealing with the variable data. P chart, application of binomial distribution, and we are dealing with the attribute data. Defects per an observation, here it is like yes or no, whether the product is good or bad. C chart, attributes data, defects per inspection, and it is basically uses Poisson distribution. Let us look at the final question, question 25 in the assignment number 9. A QC manager counted the number of defective nuts produced by an automatic machine in 12 samples. Using the data given in table below, calculate the upper limit and lower limit of the control chart that will describe 99.74% of the chance variation when the process is in control. Each sample contained 200 nuts. So you are given these samples 1, 2, 3, 4, 5. Each sample has contained 200 nuts. Out of that, number of defectives found in sample 1 is 12, sample 2 is 14 and so on, and total number of defective nuts are 144. So you have 4 options available on the screen, and you are supposed to find the upper control limit and lower control limit. So the correct answer for this question is B. UCL is 0.11037 and LCL is 0.00963. You are interested in referring to the solution. P bar is equal to total defectives divided by total sample observations equal to 144 divided by 12 into 200, which is 0.06. Sigma P bar can be expressed as square root of P bar 1 minus P bar divided by n. Substituting the values will give me sigma P bar as 0.01679, and I can easily compute upper control limit and lower control limit. So this comes out to be 0.11037 and 0.00963. Thank you very much for attending the solution of assignment 9, and with this you have covered large amount of concepts in the domain of Six Sigma. This includes the fundamentals on quality management, total quality management, quality function deployment, cost of quality, and subsequently the statistical process control, control charts, acceptance sampling, and operating characteristic curve, and so on. So, we have almost covered so far 70% of the syllabus. You have gone through the lectures during last 9 weeks and also attended the total 9 assignments, and now you can have a fair idea by evaluating your score in each assignment that how much you are progressing and to what extent your understanding is strengthened in this course. If you find you are performing less than 50%, I would advise you to once again go through the lectures, videos, the notes you have developed, and refer the textbook suggested in order to have better clarity and understanding of the concepts. Thank you very much and wish you all the best.